Good morning, sir. I am Arvind. My topic is hard disk drive scheduling scan. First of all, introduction to hard disk drive scheduling. Hard disk drives requires efficient scheduling to optimize the performance. Scheduling algorithms determine the order in which read or write requests are processed. Effective HDD scheduling can minimize seek time and improve overall system responsiveness. There are six types hard disk drive scheduling algorithms. They are FCFS, SSTF, scan, cscan, look and clook algorithms. What is scan scheduling? First of all, the scan algorithm is one of the disk scheduling methods used for managing requests. It works by moving the read or write head in one direction and servicing requests along the way. Once it reaches to end of the disk, it reverses direction and continues the service request. In this diagram, we can see that first it starts on 75 and it went up to end of the and it back again at 29:15 and 0 until it's finished. It will don't get back. How scan works? Scan algorithm services requests in a linear fashion based on their position on the disk. The head moves from the outermost track to the innermost track, collecting requests. This movement ensures that all requests are serviced before the head changes direction. For example, given requests, tracks requested 82, 170, 43, 140, 24, 16, 190. For initial head position is 50. Direction moving towards higher tracks. Processing steps are move. First of all, we have taken initial head position as 50, so we have to start from 50 to 180, 82, serve 82. And second, move from 82 to 140, serve 140. Move from 140 to 170, serve 170. And move from 170 to 190, serve 190. Last request is in this direction and we have reverse direction. Move from 190 back to 43 and serve 43. Move from 43 to 24, serve 24. Move from 24 to 16, serve 16. Here total head movement calculation is total distance traveled equals to 82 minus 50 plus 140 minus 82. We have calculating like this. There are total tracks are 238. Advantages of scan scheduling. It is reduced starvation unlike SSTF, which can lead to starvation for far off requests. Scan ensures that all requests are eventually served as the disk head continuously moves back and forth. Better response time compared to FCFS process requests in the order they arrive, which can lead to large seek times. Scan optimizes movement, leading improved average response time, more uniform waiting time because the disk head moves in a predictable pattern. The requests experience more consistent waiting times compared to SSTF, which can disproportionately favor nearby requests. It is favor for nearby requests. Disadvantage of scan scheduling. Scan may lead to starvation for requests located in the opposite direction of the head's movement. It can also introduce latency for requests that are far from the current head position. In high load scenarios, the efficiency gains may diminish, leading to longer wait times. Here in this diagram we can see C-scan. It is moving forward direction and coming back to 0 and starting again. But scan not like this. It come back and complete and at last 0 it will come. Example scenario setup. Consider a hard disk with requests at the following cylinder positions 10, 22, 35, 40, 70, 90. The current position of the disk head is at cylinder 20, moving towards the outer edge. This scenario will illustrate how scan services these requests effectively. Step by step execution of scan. First, the head starts at cylinder 20 and moves towards cylinder 90, servicing requests along the way. The requests serviced in this direction are at cylinders that are 22, 35, 40, 70 and 90. Once it reaches cylinder 90, the head will reverse direction and begin servicing requests back. Continuing scan execution. As head reverses direction, it will service any remaining request on its way back. In this way, example, it will service the request cylinder 10 on its return. The movement pattern ensures that all requests have been serviced systematically. The scan algorithm, also known as it is elevator algorithm, moves the disk head in one direction, servicing requests until it reaches the last request in that direction. Then it reverses direction and serves requests on the way back. The process continues indefinitely as long as new requests keep along arriving. Performance metrics of scan. The total seek time can be calculated by measuring the distance traveled by the head. The total seek time is it can be calculated by measuring distance traveled by the head. For example, the total distance is sum of the movements between serviced cylinders. Performance metrics help in comparing scan with other scheduling algorithms for efficiency. Scan generally reduces seek time compared to FCFS but may not be as optimal as SSTF since the head moves in a systematic way. Seek time is more predictable and spread evenly. Conclusion and key takeaways. Scan scheduling is an effective method for managing HDD, either read or write requests. Its systematic approach reduces average seek time and provides uniform wait times. Understanding scan helps in optimizing storage performance and enhancing user experiences. Here in this diagram we can see key takeaways presentation template. Thank you.